It is now recording. Here we go. Exercise 4A is to introduce you to what we call irrational numbers. So you just need to know what that means. In a nutshell, this is what it means, or by definition. Are the numbers that cannot be expressed as a fraction. So irrational numbers are numbers where you cannot write it as a fraction. Fun fact, Pythagoras was not a fond believer of irrational numbers. He killed one of these followers because they believed that there was such thing as irrational numbers. Just to give you a bit of a picture, because it was frowned upon. It's almost like saying, wait, shh. So, back then, the idea was that you start off with what we call numbers, or natural numbers, n. Natural numbers were used quite frequently. It's called counting numbers. Okay, so you would have done in primary school 1, 2, 3, 4. So we use n to represent natural numbers. And then, after natural numbers, they realized, wait a minute, if you can add, you can subtract. But if you can subtract, there was a problem when you get to 1 take away 4, for example. What's 1 take away 4? Negative 3, but that's not in the counting system because you don't count negatively. So they introduced a new number system, which is why in year 7 you learnt adding, subtracting, multiplying, dividing with negative numbers. So that was called Z for integers. So that's where your negative numbers would then exist. So you got your counting numbers, 1, 2, 3, 4, but then you got negative 3, negative 4, negative 1, but they're all whole numbers. And they said, well, you can count them, but then let's say you've got, and this back in the ancient Egypt, they used to have, for example, they have 9 loaves of bread, that's how much they made, but then 10 people come and they say, hey, I'd like to get a piece. Can you sell it to me? I'll give you this. So if you have 9 loaves of bread, but you have 10 people, not everyone's going to get a nice whole. So how much does each person get? 9, 10, yeah. So there's 10 people, so you go 10 divided by 9, right? So what's interesting is that they realized, well, counting numbers doesn't work, so they introduced fractional numbers, which we called Q, which means rational. Okay, so rational, so right here, rational, are numbers that you can write as a fraction. But you notice fractions, they were made up of a numerator and a denominator. But both of those numbers, when you write a fraction, for example, 10 out of 9, the example I just gave you, top and bottom are integers. So this is where your fractions come in, so the numbers in between. So on your number line, if you think about the number line now, you start off with 0, 1, 2, 3, 4. Then you went negative 1, negative 2, negative 3. Now we've introduced that there are possibilities of numbers in between. So Pythagoras believed at the time that, fractions-wise anyway, so you got, I'm just going to write 1/3, 1/4, 1/9. All of those exist, okay? He did not believe that there was another realm of numbers, which we call R, but that means everything that fits outside of that realm is numbers which we call irrational, which is the opposite of rational. He didn't believe there was a number that you could not write as a fraction, because he believed everything was in wholes, and especially with Pythagoras' theorem, that worked really nicely as well, until there was a problem that someone suggested. How can you get a root 2? Anyone know?
Using a calculator.
It's a root 2 is that you can have a 1 and a 1. Yeah, so you can measure 1 by 1 and then Pythagoras. Oh, actually, I'm actually skipping here. Have you guys learned Pythagoras' theorem?
Yeah.
Okay. So then 1 squared plus 1 squared equals to 2 squared, right? So if you wanted to find C, square root of that, right? Wait, no, is that right?
1 squared plus 1 squared is not equal to 2 squared.
1 squared plus 1.
Oh, you're right. What am I doing? That's 2. But then C is equal to the root of 1 plus 1 squared, right? So then it's C equals root 2.
Yeah.
Cool. Now, yeah. But the problem is, what is root 2? And he believed that root 2 was, in fact, a fraction. Is just that, how do you show it? Now, interestingly enough, I did give you the enrichment section. If you get through that, that's for you later on. But if you go through the enrichment, they guide you to prove that Pythagoras was wrong and he killed someone that was firmly right. Anyways, let's go back to our point. Here's our lesson today. Irrational numbers are numbers that you cannot write as a fraction, such as root 2. What's another one that you know that cannot be written as a fraction? Yes, so all the surds, so root 3, square root of not all the numbers, square root of all prime numbers, so root of 5, root of 7, those are all going to be irrational numbers. But can you give me one that you already learnt before you learnt surds? Who said that? Pi. Very good. But then last session of last term, I also taught you another number. E. Very good. This one, these are all numbers that are irrational. Okay, so the numbers you can't express as a fraction. Fill this in. So surds. Surds is, or what is it? Surd is, or really, just irrational numbers that use the square root sign. Okay, so when we say surds, we're actually referring to numbers where you're using the square root sign. Also known as, anyone else know? I think the Americans use this term, starting with R. Oh yeah, true. You can say root sign. It's called the radical sign. Radical. So radical. All right. So, just like how you've been learning maths so far, every time we introduce a new number system, there must be then a add, subtract, multiply, divide of that system. Just like negative numbers, just like fractions, you always learn add, subtract, multiply, divide. So this chapter 4, is teaching you to add numbers. If irrational numbers exist, well then can we add, can we subtract, can we multiply, can we divide? Write these rules down. And I'll explain why these rules work as well later. But here we go. Root x plus root y is not the same as root of x plus y. But root of x times root of y does equal to root of x times y. Yeah. And if times, just write it down. Just write it down.
What are you doing?
If times work, division would also work too. So that means when you're dividing surds, it will then be root of x over y. And then, like we already understand, squaring or square root are inverses of one another. So that means if you did root of x and you squared it, you should get the answer of x. Very good. And similarly, if you did it the other way around, if you squared x and then you square rooted it, it should give you the answer of x as well. Very good. So, yes. What's the limitation of x and y? So it means that whilst I said that x and y can be any number, there is a restriction on what any number actually means. What number can't x and y be? Well, technically it can be. What can it be? Yes. Negative. Remember, you cannot square root a negative number. Because every time you square, remember square is the inverse. Every time you square, it always becomes a positive number. It is impossible to square a number to get a negative number. Yeah, so no matter what you put in to that square, even if I put -1, the answer will always be positive. So how is it possible to square something and get a -2? Or even -4, for example? It's impossible. So that means when you square root, there's a limitation on x and y. X and y must be greater than or equal to 0. Because it can equal to 0. You can square root of 0. What's square root of 0? 0. Square root of 0. When I say square root of 0, what I'm asking is something times something gives you 0. So logically, 0 times 0, or 0 squared, gives you 0. So it is possible to do square root of 0. What's impossible is you can't do root of -1, because if I asked you something times itself gives you -1, what's that number? There is no number. Okay? Well, actually, if we introduce this system of complex numbers, then yes, you can do it. But that's in specialist. All right, team. Yes, that's right. Okay, team. So now you've copied the rules. First skill of your exercise is to identify numbers that are rational or irrational. So let's look. Is negative a third rational or irrational? It's rational because it's a fraction. Doesn't matter if it's negative or positive. If you can write it as a fraction, it's rational.
Irrational, because it can't be negative. Wait, no.
We're doing example 1, yeah? A. A is rational. Because you can write it as a fraction. No. Inside the surd, you can't have a negative. But the final answer, as long as you can write that as a fraction. Yeah. All right, next one. Shh. Let's focus. Irrational. No, because you can't. Because square root of 3 cannot be written as a fraction. No, you can have a negative on the outside. It's like saying, sorry. Shh. Thanks, Steve. Can you guys not talk while I'm speaking, please? When it gets to these kind of points, I do want to make sure that you understand. So when we're joking around, I'm okay with you chatting. But if we're getting to a point where you're misunderstanding the concept, then please don't speak while I'm speaking. I find it highly disrespectful. Okay? So just to clarify again, remember, we said that irrational just means you can't change it to a fraction. So 1/3, when you change it, it's a decimal, it's a recurring decimal. The recurring decimal can be changed to a fraction. So that's called rational. Whether it's positive or negative is irrelevant because you can have a positive 0.333, but you can also have negative 1/3, which is negative of 0.33, right? But what is irrational? Irrational is like a number pi, for example. Pi, that doesn't actually stop at that point. That's because my calculator is rounded off by 6 digits. But it goes on infinitely. And because it goes on infinitely, who says you can't have negative 3.145, whatever it is, right? Because I can. I can have negative pi. Yeah, we've got a negative, but that's irrational because I can't write that as a fraction. So the definition of rational versus irrational is just a simple idea of, can you write that as a fraction? It's irrelevant whether it's positive or negative. What I said before was that when you square root, you can't square root a negative number. Okay? But when you can square root, so why is negative root 3 okay? Because square root of 3, this is the number that goes on infinitely. That's irrational. But who's to say I can't have the negative version of 1.7332050A? Of course I can. I can put a negative in front of that. I can put negative root 3, negative, which is this button, negative root 3. I can have a negative version of that. What I can't have is I can't do square root of a negative 3. That's what I was trying to say. I was trying to say the number x, when you square root it, you can't do the root of negative 3. See, if I press Control Enter, it comes up as error. Non-real result, because it's not a real number. Until you do imaginary numbers, like what Samuel was saying, that's complex numbers. Yeah? So, at the moment where you guys are at, you're just learning to identify. If the number can be expressed as a fraction, it's rational. If it cannot be expressed as a fraction, it's irrational. And one of the common irrational numbers are roots, so radicals, the radical sign of any prime number. So root of 3, root of 5, root of 7, root of 11, all of those will be irrational and will go on infinitely. But you can have a negative or a positive on the outside. What you can't have a negative inside the square root sign. Does that make sense? Yeah? Okay, so going back to this page, why is negative root 3 irrational? Because root 3 in itself, we cannot change that number into a fraction. I know it's a negative, I just don't know what that is as a fraction. That's why it's irrational. Why is this rational? Because 1/3 I do know. 1/3 is 0.33333. I can have negative 0.3333. There's nothing wrong with that. Okay, so hence that's rational. So now let's answer the question C and D. C, is that rational or irrational? Yes. Rational, because 11% is the same as writing? Good. 11 over 100 or 0.11, but this is the definition. So it's rational, and pi we already know, irrational. Okay? All right, today's lesson. So 1 is to identify. 2 is that you got to first learn to simplify. Just like fractions. When you learn fractions, you need to know equivalent fractions. Well, now we need to work out with simplified surds or radicals. So how do you simplify root 20? This is the technique. Remember, you got your 4 rules that I just gave to you? Your 4 rules. There's no adding or subtracting here. And I said that as long as you know your times tables, you can then simplify. Your goal is that because it's a square root symbol, you need to split that 20 into 2 factors. One of the factors need to be a square number. Because if we know the square root is the opposite of square, then I can square root any squared numbers. So what's a squared number? You've got 1 squared is 1, 2 squared is 4, 3 squared is 9. So 1, 4, and 9 are called squared numbers. Now think about it. All the square numbers are 1, 4, 9, 16. What's the next one? 25. Yes? Yep. Good. Why is only one person carrying the team here? 100. 121. All right. Oh, 169. Now. All right, pause there. You need to memorize. You need to memorize the squared numbers up to at least that point. Okay, so if you don't know it, write it down. Now, my question is 20. Can you think of 2 numbers that multiply to give you 20, but one of it has to be, or both of them have to be, a squared number? What would that be? Yes? Yeah. So say that again? Oh yeah, that is the end, but I just want 2 numbers. 4 times 5. So 4 times 5 gives you 20. So what we can do is we can say, remember, your rule number 3, or sorry, rule number 2, says that you can split root 4 times 5 into 2 separate surds. So look at your rule number 2. So if I go back up, say rule number 2 says that if you can multiply within the surds, you can separate them into individual surds. So here, I can write root 20 is the same as saying root of 4 times 5. Or root of 4 times 5. Thanks, Raph. Let's speak one second. Root of 4 times 5 can be split up into 2 separate radical signs, surds. And then why did we need a squared number? Is because we know the root of 4 is 2. So 2 times root 5, we normally write it as 2 root 5 because we're too lazy to write the times symbol. Okay, just like when you do 3 times b, you don't write 3 times b, you just write 3b. It's the same thing with 2 times root 5, you just write 2 root 5. Okay? Let's try the next one. You want to simplify that 300, so think of it, 2 numbers. 30 and 10, but I want a square number in there. I want a square number. Which one did you go with? 16 and 5 works, but I can think of a bigger number. 100 is one of the biggest numbers you can come up with. 100 squared, yeah? 100 times 3. You can do the other one too. You can do 16. Would have worked as well. But I find that the larger the factor you can figure out, the better for you. So 100 times 3. Now using that rule that we just gave you, 2 times, now we can split that up into root of 100 times root of 3. But we know what root of 100 is. Root of 100 is 10. Very good. So this actually ends up being 2 times 10 times root 3. Remember, these are rational numbers. These are numbers that you can write as a fraction. This is an irrational number. So they're on different number systems. So you can't times them all together, but you can times rational with rational. So rational with rational, irrational with irrational. They're all with a different number system. Yeah? So here I can do 2 times 10. That's okay because they're both rational numbers and we can work it the way we always have with rational numbers. So 2 times 10 is 20. But 20 times root 3, we don't know. Okay, because root 3 is irrational and 20 is a rational number. So they're two different number systems. So hence we just write it as 20 root 3. All right. Wait, did I do something wrong there? No, I didn't. Next one. This one has a fraction in it, but same idea. Break the 27. Think about 27. What two numbers can you multiply? One has to be a squared. 3 and 9, very good. So when you write it out, 2 times the root of 3 times 9 divided by 3. That's the same thing as writing 2 times the root of 3 times the root of 9 divided by 3. Which number can we square root? 9. Root of 9 is good. Root of 9 is? 3. Very good. Now, same thing again. Which ones are my rational and irrational? 2, 3, and 3 are rational numbers. Root 3 is not. So when you multiply, you can only multiply rational numbers with rational numbers, divide with rational numbers, but you can't work with surds. Surds goes with surds. Yeah? So here, 2 and 3 I can multiply. 2 times a 3 I can do. And then I can divide by 3. So what's that? What's 2 times 3? 6, but then divided by 3? 2. Or if I read it more clearly, it was 6 over 3 times root 3. But 6 over 3 is the same thing as saying 2 over 1. So really you've got 2 times root 3, which is equivalent to you writing 2 root 3. So far so good? Okay, so this is just teaching the how. I haven't taught you the why this works at the moment. We just learn the how first. Okay? Yes. I don't want you to just memorize these techniques. Like these 4 rules, why do the 4 rules work? I want you to understand why it works. But that's for another lesson. So today's lesson is just the hows. All right? D. Same concept. So if rule number 2 works, then rule number 3 has to work as well, because times and multiplication are linked to each other. Sorry, division and multiplication are linked to each other. So here we go. Root of 125 over root of 16. Anyone know?
15 times 5. 25 times 5.
Very good. 25 times 5. So what you see here is rule number 3 says you can split this up into root of 125 divided by root of 16 separately. So if you can multiply them separately, you can divide them separately. Conveniently, we know that root of 16 is 4. And then someone actually mumbled out, what's root of 125? Anyone know? 25 times 5. Good. So it's root of 25 times 5. But then if you do that, that's the same thing as saying root of 25 times root of 5, because we can split them up over 4. For one of the numbers we can square root. Which one can we square root?
25.
So this here, root of 25 gives me 5. So you end up with 5, root 5 in the numerator, and divided by 4 in the denominator. So far, so good? All right. Let's give you... Did you want me to go on to the add subtract, or give you 15 minutes to practice this first before I do add subtract? All right, add subtract. Let's go. Can you skip the enrichment section? I can leave these ones for you to do. For those who don't know what positive integer means, integer means whole number. They just want you to change this into a whole number. So how do you do that? Well, to get a 2, it had to be square root of something. Square root of 4. And that's times root 5. So together, that's the same thing as writing root of 20. That is what they mean. Express these surds as a square root of a positive integer. That's my positive integer, the root 20. Okay, so 20 is my positive integer. You can try out B yourself. I'm going to stop the video for A, and then we're going to do one for B, and then I'll leave the lesson for you. Okay? Exercise 5B will be easy to do.